Hi, my name is Franco Cavallari. I'm a former Mr. IFBB North America, having used a lot of these strategies that I talk about in research today, having used them and applied them to fitness, bodybuilding, and general health and wellness in different ways. Today, over the last 20 years, I've been intensely and centrally involved in biomedical research that defines the mechanisms of a lot of botanicals and ketones and different applications for these exogenous ketones. It's a very interesting path where I've been able to take common botanicals that we know, let's for example say, have anti-inflammatory activity, strip them down into their constituents, and then with these isolated constituents map the pharmacology of each to determine how the polypharmacology of these compounds is being delivered to the body and what the mechanisms of each are, so that then we can be more selective about which constituents we use for specific indications that we know will be more reliable. And the reliability then would come into standardizing these botanicals at a different level than just the general constituent level. It's more specific, the sub-constituents that we know are responsible for the mechanisms that we are looking for that relate to different disease pathologies. For example, curcuminoids. Regular curcumin is made up of 3 curcuminoids typically, and although we've all thought in the past that each of these curcuminoids have similar anti-inflammatory activity or mechanisms that are similar to generate this anti-inflammatory activity in the body, we've isolated mapped the pharmacology of each curcuminoid, and then been able to put together this curcumin that has more reliability because it's standardized in terms of the proportions of these 3 curcuminoids to be highly selective for a target, a proteomic target that we're looking for that relates to a disease pathology. When it comes to the ketones that we're talking about here right now, we've done a lot of research on beta-hydroxybutyrate and other ketones that are generated in the body from the BHB. Typically the BHB is considered a ketone body, but we can supplement with this exogenous ketone to induce ketosis, a rise in serum ketone levels from the baseline, which is typically 0.1 millimole for the average person. It can range to a different level for some people based on caloric intake, carbohydrate intake, and or physical stress and strain, physical load in particular. Exercise is one way to facilitate ketosis as well, in conjunction with a diet that's ketogenic. So we engage in a ketogenic diet. Obviously a ketogenic diet is low in carb, mediocre in protein, because protein can contribute to glucose through gluconeogenic amino acids that are converted into glucose in the body, and then a higher level of fat, so that we're forcing the body to try and use this fat as a primary substrate for ATP synthesis in the cells. But for a lot of people, it can take 72 hours or even more to generate enough ketones upon commencing a ketogenic diet. So for the 72 hours, while serum ketone levels rise from baseline, the brain is not getting the energy substrates it needs, because as you drop glucose levels or drop carbohydrate intake, serum glucose levels tend to decline as the glycogen is used up, and if serum ketone levels haven't increased or incrementally risen to meet ATP levels and synthesis of energy by the brain, synthesis of energy with ATP, then the brain starts to starve. Fats cannot cross the blood-brain barrier effectively, and that's why the brain can't use these fats. And so it waits for these ketones that are generated in the body through a process called beta oxidation, primarily in the liver. There are other cells that can engage in beta oxidation to make fats their energy source. So we're converting fats through beta oxidation to ketones, and this rise in serum ketone levels through endogenous or internally derived ketones. This rise then can feed and fuel the brain as the ketones cross the blood-brain barrier. Now the cool thing is that there are diseases, epilepsy, dementia, just general deficit and recall failure in the brain that can be served well by an elevated level of ketones. We know that dementia is associated with a term called type 3 diabetes, where insulin is not functioning effectively in the brain to allow glucose to be taken up by the neurons so that glucose can be used as a primary substrate for ATP synthesis. And in these cases where we have this type 3 diabetic state, this elevated serum ketone level is an amazing resource for the brain because it crosses the blood-brain barrier. The ketone is not dependent on insulin to penetrate or enter the cell, and so it's assimilated or absorbed into the cell, used as a primary substrate for energy, for ATP. But the cool thing is that the brain can actually make, the cells can actually make more ATP per carbon of ketone than it can of glucose with less oxygen. So there's a lower demand on the cardiovascular system for oxygen exchange, and the brain can actually make more ATP. When you cause an increase in serum ketone levels that the brain is happy with, you begin to see the room feels brighter, cognition is more readily functional. You feel awake, you feel energetic, you feel like doing things you didn't want to do before when you're carbohydrate loaded. So for a lot of people, especially those who are insulin resistant, we find those who are insulin resistant or pre-diabetic or into the type 2 diabetic state do really well with this exogenous ketone supplementation. The challenge is, if you take a regular ketone salt, like a BHB, ketone body supplement, or ketone ester, you take this exogenous ketone supplement, you can cause an increment in serum ketone levels very quickly, within 10 to 15 minutes of actually consuming it. So it's quite effective. And every 15 minutes you can actually map a rise in serum ketone levels while mapping a reduction in serum glucose levels, because you have a facilitated clearance of glucose. So the cool thing is that this supplement can actually allow you to go into ketosis through the exogenous ketone that's taken, and bypass that 2 or 3 day period where you feel lethargic, or you have that ketone flu, or that low carbohydrate flu as they call it. So the challenge we face is that if you are engaging in a ketogenic diet for reasons of inducing ketogenesis, and you take this exogenous ketone to cause serum ketone levels to rise quickly, you actually inhibit the ketogenic process, because the feedback mechanism from this elevated serum ketone level will cause the ketogenic process to be inhibited. And also you inhibit lipolysis. And so here what we do is we inhibit not only lipolysis and ketogenesis, but fatty acid oxidation. So our research from our lab has been published in the Journal of Obesity and Diabetes. I'll get the specifics to you if you give us a request. And it shows how a regular ketone salt, ketone body, BHB, beta-hydroxybutyrate, taken as a supplement will cause serum ketone levels to rise. But fatty acid oxidation is shut off, ketogenesis is shut off, and because ketogenesis is shut down, the production of endogenous or internal ketones is shut down, which means your fat is now not being used to generate ketones through beta oxidation. When you take Ketoba, which is the beta-hydroxybutyrate coupled to BA, butyric acid or butanoic acid, this is a short-chain fatty acid, not a medium-chain triglyceride, short-chain fatty acid coupled to the BHB. What happens is, you take this, you need lower levels of the BHB to induce fat loss, to induce fatty acid oxidation. And that way you don't have to burn through the calories of the BHB. Keep in mind, when you take this exogenous supplement, they have caloric value of about 5.4 to 5.5 kilocalories per gram, which is more than a carbohydrate, which is 4 calories per gram, more than protein, which is 4 calories per gram, less than fat, which is 9 calories per gram. But still, it's a calorie you have to get through. So the more you take is not better. The reason why we've got these high doses of ketones in supplements in the marketplace is because the research originally done using these exogenous ketones was done to demonstrate how we can reduce the frequency of epileptic seizures. And so we want to get serum ketone levels high enough to engage and induce this effect. But when you do that, you inhibit lipolysis. You inhibit fatty acid oxidation. You inhibit ketogenesis and the use of your own fat as a source of energy for ketone generation. So with Ketoba, the difference is you take Ketoba, which is the beta-hydroxybutyrate, the exogenous ketone or ketone body, coupled to butyric acid or butanoic acid, the short-chain fatty acid. That butyric acid goes in and signals the liver. It's a ligand that signals the liver, tells it to activate beta oxidation and keep it in motion while you supplement with this exogenous ketone to cause serum ketone levels to rise. You don't want them to go too high because then you inhibit lipolysis and lipogenesis, or lipolysis, you inhibit ketogenesis. But you want them to be high enough to stimulate the brain. And when you take it, you'll notice suddenly the lights are brighter. I have way more energy. If I engage in physical activity, I can go forever. Why? Because I've stimulated the brain, the body's getting what it needs, and you've trained and told your body to make ketones from fat. You'll never run out of fat no matter how lean you are. And you will continue to make these ketones from your fat during your physical activity. The cool thing is that most of us, if we engage in physical activity, let's say you're on a carbohydrate or you're in a cardiovascular program where you're training on a treadmill, you want to burn fat so you're not high intensity, you're just above medium intensity. It takes roughly 15 to 20 minutes for the average person, 15 to 20 minutes initially on that treadmill to begin to burn fat through that activity. The interesting thing is that the first 15 minutes of that cardio training, you're burning off all the glycogen in your body with some fat. And then as your body kicks in at about 15 to 20 minutes to begin to use a higher caloric requirement or demand because of the physical activity, the oxidation or burning of fat increases and the carbohydrate level tends to moderate itself. So you're using more fat at about 20 minutes. But most of us don't last more than 30 minutes on a cardio program. So a 30-minute training session, you burn fat at high intensity levels for 10 to 12 minutes. If you take ketoba, beta-hydroxybutyrate coupled to the BA, you burn fat from the minute you start your physical activity because this bypasses this lag period and causes your body to burn fat from second one, as soon as you step on and you go. And you can feel it because even within 5 minutes of being engaged in this cardio program, you start to feel like, oh my gosh, I can go, and I can keep going. Because your body will require less oxygen to make more ATP using the ketone as a substrate for ATP generation or synthesis than it can make using glucose. And this is how this works to help you get through endurance activity, help you get through physical activity that's specifically designed for fat loss to just get you in the condition you're looking for. Ketoba, or the BHB coupled to BA, the butyric acid, also called B-ketone. Now, B-keto or B-ketone is a product that is made with the BHB-BA. The BHB-BA itself is the central mechanism for B-keto. B-keto is game-changing also because it is sweetened with glyvia. Now here's the really cool principle when you combine BHB-BA with glyvia. And this is what's really key about the B-keto. B-keto couples these two activities and these two technologies because the glyvia helps the body reduce blood sugar. Now, I mentioned earlier, if we engage in physical activity and try to use the ketone and the fat as a primary source of energy, and serum glucose levels are high, the body will try to use glucose as a primary substrate. But when we combine this with glyvia, which can help blood sugar drop because it induces an insulinogenic effect to push glucose out of the bloodstream, we cause the serum ketone that is high, that has been raised by the B-ketone, to be the prevalent source of energy in the bloodstream. So the ketone then is prevalent over the carbohydrate or glucose, and then your cells will use that exogenous ketone as the primary source of energy. That exogenous ketone will be met by the endogenous ketone that your body's making from your own fat because of the butyrate signaling the liver to tell your body to continue making despite the fact your serum ketone levels have risen beyond your baseline.